the first video of Carbanion chemistry. I have also discussed two other intermediates, that is carbocation and carbene, and the playlist link for these two intermediates you will get in the description box. Let's start. So what is carbanion? It is carbon and it is carrying some negative charge. So it is anion. So carbon and anion together we can use the term carbanion. So carbanion is an anion in which the carbon, obviously it bears a negative charge. As you can see in this picture, carbon is carrying negative charge and there are three bonds. Now which groups are attached, that I have not mentioned because this is the general structure. It may be any groups, but carbon should bear a negative charge. Now how many electrons will be surrounding carbon in carbanion? It is basically total 8 electrons. Now out of these 8 electrons, 6 are coming from 3 covalent bonds. Here you can see 3 covalent bonds are present and these are the electrons that are present in this bond. So here you can get 6 electrons from 3 bonds and the rest of the 2 electrons that are coming from this negative charge. So this is unshared pair of electrons. And if we see a quick example of, very simple example, basically how the carbanion is generated. Here we have taken this molecule where carbon is attached to 3 groups. Which groups, that is not mentioned, but here it is also attached to Z. Now carbon is, suppose if carbon is having more electronegativity than Z, then after cleavage of this carbon Z bond, that is heterolysis. Heterolysis means both the electrons in the bond between carbon and Z, it will come over C, not Z, as C is more electronegative. So here Z is leaving with this positive charge and both the electrons that are present in this bond, now it will come over carbon. So that is why it is carbanion. Here also 6 electrons coming from 3 covalent bonds and 1 unshared pair. Total 8 electrons. Carbanion is trivalent, so there will be total 3 bonds. As you can see here, 3 bonds are present. But remember, not necessarily there will be 3 substituents. That is not necessary. It may be so. As you can see here, 3 substituents are present, 1, 2, 3. But not necessary, because the structure, if it is like this, suppose carbon, there is a double bond and there is any group and it is also attached to some other group, or still there is some negative charge. So in this case there are 3 bonds, that is fine, but only 2 substituents. Similarly, if there is 3 bonds and it is carrying negative charge, here also 3 bonds are present, but not necessary that you will have 3 substituents. Fine. And it can act as base or nucleophile as it is carrying negative charge. So suppose if I am writing this carbanion like this and there is hydrogen present in any other molecule. Now this carbon, if it is attacking this hydrogen and we are getting now CH bond and R, there is now negative charge. So here it is capturing hydrogen, that is proton, so that is why it is acting as base. But it can also act as nucleophile. Now nucleophile, this term mostly we use organic chemistry. What is the difference between base and nucleophile? Base means the negative charge over carbon, it is attacking proton. But suppose instead of attacking proton, if it is attacking some electron deficient, suppose I am writing here any positive charge over carbon. Not necessarily it is positive charge, but if it is attacking any electron deficient atom, mostly I will use here carbon because we are talking about organic chemistry, and whenever there is attack by nucleophile, it is mostly over carbon. So instead of attacking, when the negative charge over carbon is attacking any electron deficient carbon, then you will call it nucleophile. So that is the difference between base and nucleophile, but it can act as both. Now here we have this example, which is mechanism of E1CB. So in this E1CB, though mechanism can vary, now in this particular case I have taken it in such a way as if here the first step, this is the first step, this is the second step. Here the first step is fast and the second step is slow. Okay, so in the first step what is happening, this is basically alkyl halide. This carbon hydrogen bond is broken and you are getting negative charge over carbon. So this is the carbanion intermediate, and in the second step this carbanion, it is making a double bond between these 2 carbon. As a result, this X will be removed as leaving group. So this is the mechanism of E1CB. where we are considering the first step as first. Now again I am saying this is not necessary. So we have taken the example in such a way where the first step is first. So if that is reactive intermediate, if we see in detail what it means actually. So reactive intermediate, it is high energy, obviously, as it is intermediate, it is not stable final product. So it will be high energy, but there will be some kind of stability, and it's a high energy yet stable product that exists only in one of the intermediate states. So this is not the final molecule. Further reaction will take place. So as you can see here, suppose if this is A, this is B, and this is C. Here A is starting material, C is final product, and B is intermediate. So this is not a final product. There are total 2 steps, and in between 2 steps the species that we have, that is actually the intermediate. After generation, it will quickly convert into more stable molecule. So this is the general definition of intermediate, which is also applicable for carbon, carbocation, carbene, like this. Okay. So this is reactive intermediate definition. Now for this reaction, if we see the energy profile diagram, where the first step, as you can see here, this is the first transition state, this is the second transition state, and this is the intermediate carbanion. First step, as it is first, so its activation energy, obviously it is less compared to the second one, that is clear from this picture. So this side we have reactant, which is A, and in the right hand side we have the product, and this is the position of intermediate. So as it is mentioned here, that it will have some kind of stability, that is compared to transition state 1 and 2. If you see energy in y-axis, obviously it will have some stability, but not like the final product or the initial reactant. Okay, so that is why it is reactive intermediate. It will have some kind of stability, but still it is reactive. Now what are the types? Alkyl carbanion. So in alkyl carbanion, that is the simplest example possible is CH3 minus. That is, if we remove one hydrogen from methane, you will get CH3 minus, where the hydrogen is removed in the form of H plus. Similarly, we can have CH3, CH2, CH2 minus. This is 1 degree carbanion, because this carbon is attached to only one carbon. Then we have 2 degree carbanion. So this is basically CH3, CH negative charge, and CH3. Now this carbon is attached to 2 carbons, so that is 2 degree. And the last one, C negative, it is attached to 3 CH3 group. So this carbon, which is carrying negative charge, it is attached to 3 more carbon, so that is why it is 3 degree. So all these are examples of alkyl carbanion. Next, alkenyl carbanion. Now in alkenyl carbanion, this carbon which is carrying the negative charge, that is attached to, but there is one single covalent bond, but there is also a double bond. So CC double bond here we have, and this is the general expression. But if we actually see this R group, suppose it is hydrogen, the simplest example possible for this general structure, CH2 double bond CH, basically the negative charge is over carbon. So here also you can see it has 2 substituents, but total 3 bonds. Fine. So not necessary 3 substituents we will always have. Alkynyl carbanion, CC triple bond, and this is a general structure. And if we have this R group, it may be hydrogen also, but here we have CH3, so it is CH3 C triple bond C negative. Some more examples. Aryl carbanion. So in aryl carbanion, now as if we have any benzene ring, and if you are removing this carbon hydrogen bond, that is if you are removing hydrogen, you are breaking CH bond, so negative charge will be directly over this one of the carbon of benzene ring. Then allyl carbanion. So just like allyl carbocation we have seen in carbocation videos, now it is that is this CH2 double bond CH, this type of group, it is attached to CH2, so that is why it is allyl carbanion. Now this type of carbanion, there will be conjugation probabilities there. And then we have benzyl carbanion. So benzyl carbanion, just think about toluene, and if you remove any of these carbon hydrogen bond, then you will get this pH CH2 minus. Here also probability of conjugation is present. Okay, so these are the different types of carbanion. So that's all for this video. I will come with some more features, that is stability, generation, all this regarding carbanion. Okay, thank you for listening.